morning. So today we're going to be looking at maths, and we're going to be looking at if it's a little bit more complicated, if the numbers get bigger, or how we can work out what the mass of something is. Okay, so for this morning's starting activity, we're going to do another flashback. This time you're going to be telling me, first of all, not what the clock is, because I haven't got a clock, but you're going to be telling me what this shape, 3D shape, is here. If you don't know it, don't worry about it, because we will be going into looking at these. However, if you do know it, fantastic. Then for number 1, you're finding a quarter of 320 grams. So just like we'd used last week, and the other lessons on looking at finding a fifth of lemons or a third of oranges, this time it already gives you the number that you're trying to find a quarter of. So having a go at that, remember if the number's a big number, if it's got a 0 on the end, think about what you could do to maybe take the 0 off. Number 2, you're then going to find 3/4 of 320 grams. Number 3, you're completing the part whole model, thinking about if it's a whole that is in the whole part, what would that be as a fraction, using your other parts to give you an idea. And then you're adding 345 and 274 together. So have a go at doing that. Once you have done that, press play on the video and we'll see if you've got the right working out and found the answers correctly. Okay, so if we have a look at our shape that we've got here, we can see that there is a square on the top, a square on each of the sides, and that they are all equal in their size, in their shapes on each. So we know that this is going to be something that has got a square on it. Now if we think of our 3D shapes, the only 3D shapes that we can think of that have got squares on are a cube, a cuboid, or sometimes if it's a square-based pyramid or square-based prism as well. So obviously we're going to have to think of that now. Now if they're all the same size and all the same length of each of all the faces are the same size, all the edges are the same length, and they've got the same number of and they've got angles, then we can see that this one is clearly going to be a cube. So you should have said that this one was a cube because each of the faces, so the sides of them, are the same shape, they are also the same size, and all the edges are the same length as well. Because obviously if it was a cuboid, there will be some rectangles that you would see on that shape as well. Okay, so let's have a look at number 1. So number 1, 1/4 of 320 grams. So we already know that we've got, we're trying to find a quarter. We know that there are 4 parts, so we can already draw our 4 parts. Now, we know our total number is 320. So I want to do 320 divided by the number of parts. So divided by 4. So 320 is my total number, and I'm dividing it by the number of parts. However, if you were to go and dot in here, 320 is a pretty huge number to go and have to dot or to count up in your 4s. So what we can do is we can take off the 0 for now, and we can do 32 divided by 4. Now if you know your 4 times tables, you might be able to tell me the answer straight away. If not, you could go and dot it 32 times in your circles to share it out. Now for quickness, and for those that might have been able to do it quicker, let's do our 4 times table. 4, 8, 12, 16, 20, 24, 28, 32. So I know 32 divided by 4 is going to be 8. So I know in each of these I should have either had 8 dots, or you could have just wrote the answer 8 in each of them. Now I need to look to see how many parts does it want. Well, it only wants 1 part. So if I find 1 part, I know my answer is going to be 8. However, it's not going to be 8, remember, because we took our 0 off. So we need to put our zeros back on. So make sure that you've put your zeros on in there. And then we can see that our answer isn't going to be 8, it is going to be 80. And don't forget to put your grams on the end. Okay, so now we need to find, for number 2, we need to find 3/4. So we could have done it all again. However, if you had looked at the question, number 1 and number 2 were using the same number of parts, the same total number, so we don't actually need to work it out because we already know what 1 part is worth. So 1 part is worth 80. So what I could do is this time, in order to find, I'm just going to take off my blue there. So this time I want to know what 3/4 of 320 grams is. So this time I'm going to look not at 1 part, not at 2 parts, but at 3 parts. So I can now draw my circle around 3 parts. So I know that I have got 80, 80, 80. So I need to do 3, because 3, that's a number, 3 lots of 80. So 3 times 80. Or alternatively, it's got a 0 on the end. Take off your 0 for now. 3 times 8 is, if you do your 3 times table or your 8 times table, 8s are quicker, but 3s you might be more confident with. 8, 16, 24. But remember, you need to then put your 0 back on that you've taken off. So your answer would be 240 grams. Okay, I'm going to give you another question similar to this one now that I'd like you to have a go at working out using the same method that we've used here. Just because it is a bigger number, take off your 0 and put it back on at the end. Okay, so I'd like you to have a go at working out this one. 1/5 of 450 grams. Once you've worked out what 1/5 of 450 grams, I'd then like you to tell me what 3/5 of 450 grams are. Now, to really push yourself and to really challenge yourself, you could then, as a bonus, you could then tell me what 2/5 would be and what 4/5 would be. So if you want to push yourself as a challenge, you can tell me what each fifth would be worth. So go and have a go at this, pause the video, please then play the video and we'll see if you've got your working out correct and see if you've made sure that you've understood it all as well. So to start off, I'm going to do, look, I've got 5 parts. I've got 1, 2, 3, 4, 5 because I'm dividing by, because I've got 5 as my denominator. I know 450 is going to be my total number and I'm going to divide it. I'm going to share my 450 and I'm going to just make that bit clearer. I'm going to divide it by my total number of parts, which is 5. However, 450 again is a huge number and we're not going to dot that or count up in 5 still 450. We can therefore take off my 0. 45 divided by 5, you can either dot it 45 times or we all know our 5 times table, let's count up in 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45. So I know 45 divided by 5 is 9. So I could write 9 in each of these. However, remember we've taken off our 0, so we now need to put our 0 back on. So I know that 1/5, if I now was finding what 1/5 is worth, I would look at 1 part and I would say that 1 part was worth 90 grams. Fantastic. So now this time I'm going to use a different colour to make it clearer. So I've worked out what 1 part is worth. So if I want to work out what 3 parts are worth, I need to do 3 times how many is in each one. Well, I've got 90 in each one, so I could do 3 times 9 is 27. And then put your 0 back on, because remember, just take off your 0 and then put it back on. So 3/5 will be 270 grams. And don't forget your grams. Now, if we have a look for your bonus points, if I was looking at 2/5, I could do 2 times 90 because I know there's 90 in each and I want to know what 2 parts are worth. 90 add 90, or I could do 2 times 9 is 18. And then put your 0 on the end and your grams. And then finally 4 parts are worth. I'll use different colours again. This time I want to know what 4 parts are worth. So I have got 4 lots of 90. 4 times 90. 4 times 9 is 36. And then put your 0 on the end to find 360. So fantastic if you found 1/5 was worth 90. 2/5 180. 3/5 270, when I've forgotten to put, oh, I've got my 2 grams there, 270 grams. 4/5 were 368, and obviously 5/5 would be a whole because the top and the number, bottom number are the same, so that would be 450. And if you can spot it, if you take off the zeros and all of your answers, it is actually going up in its 9 times table. I'll put your 0 on and the 90 times table. Okay, so let's have a look at number 3. So number 3 needed to complete the part-whole model. Now remember, a part-whole model, all it means is that the whole, which is the one which has got 2 lines joining to it, that is the whole, because that means that these 2 numbers here are going to add, their parts are going to add to make your whole. Now, if I have a look here, I have got 1, 2, 3, 4, 5, and it says I have got 2/5. So if I drew that as a bar model, you can see I have got 2/5. Now it says I want to know what this one is here, but I have got a whole here. Now remembering a whole, the numerator, the top number, and the denominator must be the same. So if I look to see what my parts are, I can see that my parts, I've got 5 parts. So for my whole, I am still going to have 5 parts because we're adding 2/5 to something to make our whole. So 1, 2, 3, 4, 5. So I know my denominator is going to be 5 because if I look at my denominator on this one here, I want to know what number I add to this to equal, so it's got to have the same denominator. Now to make my whole, let's see how many fifths I've got to colour in. 1, 2, 3, 4, 5. So I know it's going to be 5/5. Now I know this because my top number and my bottom number are the same, which means it is a whole. So now if I have a look at my bar model here, I know I've got 2/5 and I need to get to 5/5. So if I work out how many I've got left over, so I have got 1, 2, 3. So I've got 3/5 left over because if my denominator stays the same, 5 and 5, if I add 2 and 3, I would equal 5. Okay, I'm going to give you another question like this and I want you to have a go at doing it. You can always draw your bar models so you can see them as well. Okay, so I'd like you to have a go at doing this one. So I've got 4/9 in one of my parts, I don't know my other parts, and I want to make a whole. So remembering, just like you did for this one, you could draw your bar models, you could tell me what your whole would be, and then you could work it out. So off you go and have a go at doing that one, and then play the video once you've done it to see if you've got the right answer. Okay, so let's have a look. So if I was to draw this as a bar model, obviously you would have used a ruler. I'm just doing it for speed. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, I've not left enough space there, but we can see I've got 9 parts, so I have drawn 9 parts because 9 parts is my denominator. Now if I shaded 4, 1, 2, 3, 4, because my numerator is 4, I can see that I have used 4/9. Now I know that my whole has to have the same numerator as the same denominator. So if I have a look at what my denominator was used here, I know it's going to have to be the same because I want to make the whole, and I know to have the whole number, my top number and my bottom number would be the same. So in order to find the missing one, we need to know how many ninths do we add to 4/9 to get to 9/9. So we already know that my denominator is going to be 9 because it has to be, because all the other denominators are 9. And if I count 1, 2, 3, 4, 5, I can see I need 5/9 to add to 4/9 to equal 9/9. Alternatively, you might not have used a bar model. You might have just put 4/9 add something equals 9/9. So if we had a look at this, I know my denominator's got to be 9 because we don't change our denominator when we're adding unless they're different denominators. So what do I add to 4 to get to 9 would be 5. So 5/9 would be the answer. Fantastic if you got that, well done. Finally, for number 4, this should have been a nice easy one. You are adding 345 and 274 together. So using your column method, 5 add 4, starting your ones, 5 add 4 is 9, 7 add 4 is 11, but remember we can't put 11 in one column, we have to put the 1 in there and exchange our 10 tens for 100, so we can see that it says 11, and then 3 add 2 is 5, add your 1 is 6, so you should have got 619. Fantastic if you've got that, well done. So quick recap, what measurements have you heard of? You should have said millimetres, centimetres, metres and kilometres, grams and kilograms, millilitres and litres. So we've obviously started to look at some of these. So last lesson we were just having a look at what mass was, and we knew that mass was the weight of something, how much something weighs. We also were learning that when we weigh things using grams and kilograms, and that there were 1,000 grams in a kilogram, or in 1 kilogram there was 1,000 grams. So we did some converting last time, so to really help you understand how many grams are in a kilogram. So this time we're going to be having a look at converting both, using both kilograms and grams, but also to convert it all into kilograms and all into grams as well. So it's a bit of a challenge today. So the first thing I need to do is I need to look at how much the weights weigh. So remember from last time what were our steps to success? First thing we need to do is look at what the unit of measure is. So I can see from this it's in kilograms. The second thing I need to do is looking at the increments to see what the measurements are going up in. So if I look at my weighing scales, I can see that they are going up in 1 whole kilograms. So I can see where my hand is. Now my hand is halfway between the 3 and the 4. So I will know that it will be a number between 3 kilograms and 4 kilograms. See if you can have a go before I tell you the answers. What do you think the answer will be? So if you did it in kilograms and grams, just did it in kilograms, or just did it in grams, what the answers would be. Okay, so let's have a look to see if you got the same as I did. So I can see that the hand has gone past 3 whole kilograms. So I know that I've got 3 kilograms. Now, the hand is halfway between 3 and 4 kilograms. So I know that that is 1 kilogram difference, and if it is halfway between them, it's going to be worth 500 grams. So I know the first answer will be 3 kilograms, 500 grams. Okay, so now we can convert it. Now, we can use our thousands, hundreds, tens, and ones column to work out what these are. Now remember, if I have got 3 kilograms, I know that there are 3,000 grams in a kilogram. So I know that I've got 3,000, I've also got 500 as well. So I can add those two numbers up and I can get the answer 3,500 grams. So that could have been one of your answers. Now if we were to convert it into just kilograms, we can see I've got 3 whole kilograms, I have got 500 grams left, so I've got 3 whole kilograms, 500 left, so it will be 3.5 kilograms. Okay, so I'd like you to have a go at doing the next one then, and then we'll have a look at the answers. So the next one is looking at the weight of a car. So have a go at doing this, finding it in kilograms and grams, in kilograms and in grams. If you can just do one of them, that's absolutely fine, but challenge yourself to do all 3 and then we'll have a look at the answer. Okay, let's have a look at the answer then. If you haven't yet, please do first. So I can see that if I look at my units of measure, it's in kilograms. And I can see that my increments are going up in 1 whole kilograms. Now it is also going up in little ones as well, so you have to work out what each of these individual ones were worth, and you should have worked out that each one was worth 100, because remember in 1 kilogram there is 1,000, so each little line should be worth 100. So I know straight away that my hand has gone past the 4 kilograms, so I already know I've got 4 whole kilograms. Now, when I have a look at my grams, I need to have a look so I can put my hand on the 4 and I can count up in hundreds, 100, 200, 300, 400, 500, so it is 500 grams, and you can actually see that it is halfway between the 4 and the 5 also. So if I was to write this as a kilogram, I know I would have 4 whole kilograms, put my decimal point. How many grams have I got left? I've got 500, but remember I don't need to put my zeros. I can just put my I can just put my kilograms like this. Now, if I was to convert this, I know that in a kilogram there is 1,000. So in 4 kilograms, I'm going to have 4,000, and I've got 500 left over. So I should have the answers 4,500 grams. Check to see if you've got that right. If not, can you see now where you might have gone wrong? Okay, can you now have a go at doing this one, and then we'll have a look at the answers and see if you've got the same answer as me. Okay, let's have a look at the answers. So we can see that if we look at the unit to measure, it is in kilograms. We can see that the whole kilograms are going up in one whole kilograms of the large numbers, and I also can see that the little numbers are going up in hundreds, because remember there are 1,000 grams in a kilogram. So I can see that I have passed 2 kilograms, so I know that they weigh more than 2 kilograms. Now if I count up in hundreds, I can count 100, 200, 300, because I'm counting the little numbers now, so I know that there are 2 kilograms and 300 grams. Now if I was to write that as a decimal, I know that I've got 2 whole kilograms, so I will put my decimal point. I know that there are 300 grams left over, but I can just put 3 because I don't need to put the zeros, and then I can put kilograms, and my answer will be 2.3 kilograms. Now if I was to convert this all into grams, I know in 1 kilogram there's 1,000, so in 2 kilogram there are 2,000, so I can put 2,000, and I've got 300 grams left over, so my answer should be 2,300 grams. Now you might get a question like this where you have to actually draw the hand on yourself. So we need to draw the hand on for 1 kilogram and 700 grams. So first thing, we need to double check what our unit of measure is. It is going up in kilograms. The second thing, we need to see what our increments are. We can see that the large numbers are going, the large lines are going up in 1 kilograms, and all the individual little lines are 100 grams. So if I find first of all where my whole kilogram is, so I need to go to 1, so I will move my finger to where it says 1 kilogram. Then I need to count 700 grams, so I need to count 7 little lines because each line is worth 100. And then you can draw on your arrow to the correct place. Please make sure that this is accurate, as it must be accurate, otherwise it won't be correct. So your answer should look something like mine, so that it has gone past the 1 kilogram point and it is 700 grams. Okay, I'd like you to have a go at doing this one now and finding on the screen, pointing to the screen where the arrow should go, making sure it's accurate, to find 2 kilograms and 100 grams. Your answer should look something like this, because it has gone past 2 whole kilograms and each little line is worth 100 grams, so it is pointing to the little one, the little line after the 2 kilograms. Okay, you might come across questions that look like this, and these are a challenge. So the chocolate bar weighs 100 grams, so we know how much the chocolate bar weighs. How much does the muffin weigh? So we need to know how much the muffin weighs, and then we need to work out how much each side weighs. So have a think, don't work it out yet, but have a think, how do you think you could work it out? And just a top tip, each side weighs the same because the scales are equal, they're balanced. They're not one up, one down, they're balanced. So this is how you could do it. You could draw a bar model to show that on one side we've got 3 muffins, and on the other side we've got 2 chocolate bars and a muffin, which weigh the same. So I can see that my bar model is the same. Now from looking at this, I can see that 1 chocolate bar weighs the same as 2 muffins, because the muffins are all going to weigh the same. So in order to find out how much each muffin is worth, we need to do 100, because that's how much the chocolate bar weighs, divided by 2, because I know 2 muffins are the same as 1 chocolate bar, which would get me the answer of each chocolate bar would weigh 50 grams. Now, It then says how much does each side weigh. Now we know that each side is going to weigh the same because they're balanced, so I can work out 3 muffins, each one weighs 50 grams, so I can do 3 times 50, which is 150 grams. Alternatively, I already know the chocolate bar weighs 100 grams, I know a muffin weighs 50 grams, so I can add those two numbers together to say the other side weighs 150 grams too. So I'd like you to have a go at doing these questions now. So you've got somewhere you're telling me what the weight is, you're telling me somewhere you're drawing the answers, and then I'm going to go through the answers after to make sure you've got them all correct. Okay, so let's have a look. So number 1, you should have counted, it's going up in grams, and we can see that each increment would be, you need to work that out first. We can see that each increment is going up in 50 grams, so if you counted it up, the answer would be 700 grams. The second one, we can see that it is going up in 100 grams is each little line, so if you counted that up, you should have had 1 kilogram 700 grams, or if you'd have wrote it as 1.7 kilograms or 1,700 grams. The next one, we can see that they are going up in 100 grams again at each little line, so if you count that up, you've got 2 kilograms and 400 grams. Alternatively, you could have had 2.4 kilograms or 2,400 grams. Okay, the next one, you had to look at the top to see how much each of these objects weighed, and then you had to go and draw on the line where this was. Now please try and get this as accurate as you can, so look at my answers to see if you've done it the same. Okay, for number 3, we had to say what each were worth. So again, we had to work out what each little line was worth, and we could see for the tennis ball they were going up in 200 grams, so the answer would be 200. We could see for the laptop that they were going up in 200 grams again, so the answer would be 2 kilograms and 400 grams. And for the cat at the bottom, we could see that the little lines were going up in 250 grams, so the answer would be 4 kilograms and 250 grams. It says, how did you work out each interval on this? How did you work out what each interval on the scale represents? So the interval was the same as an increment, so what each little line represented. So if you've told me a fantastic answer there, I'd love to see that. For number 4, Whitney is weighing some objects. Do you agree with Whitney? She says the book weighs more than the toy bricks because the arrow goes further round. Is she correct? Well, no, because actually both are weighing. So the book actually weighs, if we have a look and count it up, we've got the book will weigh 1 kilogram 800 grams, whereas the a brick weighs 3,500 grams. So it doesn't matter if the hand's further around the face, it actually means you've got to look at the increments first to see what the numbers are going up in, to see which is going to be the heaviest scale. So obviously please make sure you've said something and include the words increments or intervals, and you've explained your unit of measure as well, so please try and get that into your explanation. And finally, number 5, Amir and Annie each have a present. They are working out the mass of their presents using weights. So our presents weigh the same, Amir says, and Annie says, no they don't, mine is heavy because it weighs more than a kilogram. Well, they are both correct because they do weigh more than a kilogram. However, Amir is more correct because he's said that even though that they've got different weights on the scales, if you add all the weights up together, they are the same. So that is why the balance is the same.